Hello, hello, hello. Good afternoon, good morning, good evening from wherever you. Give me some love smiley or thumbs up if you can hear me clearly. Good, good, good. Chris Dan, I can see you. I see the love smiley. So yes, we go. Welcome everyone. And yeah, it's good to have us here. AI was gonna steal our jobs. Now, kept us in the driver's seat on how to ensure that our job is being done with the best value possible, delivering the best outcome as we can. Yes, let's go. I can see you ignite. Okay, so today is week going back end. You remember we spoke about ML, machine learning, deep learning, and the AI, the back end drivers of the AI tools and AI platform we see today. We're looking into data science, into a lot of analytics, machine learning, deep learning, what have you. Um, we have Anuba. We have so many statistical analysis done in data science, and we use this in making very decisive decision and taking decisive standpoint at the end of the day. And you can see how unique our what I'm sharing on the left hand side for you all is data. I don't think you can make meaning of the data you see on the left hand side. We have so much. We have both numerical data, we have both categorical, we have string data, we have words, we have letters, we have numbers. How do we clean this up? And how do we use this to create value? Or consequently would help us with the final decision taking. Give me a thumbs up, give me a little smiley if you can hear me clearly up to this point. Okay, yeah, I see you. A check one. I can see you too. Okay. So I would like us to dive in. So it's the master class. Today is the data science aspect we'll be looking at. This is a live section on YouTube. I would state that we had some certificates sent out last week. I mean this week, but it's related to the last week section we had. 15 certificate already has been sent out. So all we just need to do is to follow the rules, follow the requirements, and at the end of the day, we get ours. So for this section, I must repeat, just as we've joined in, understand that we'll be having questions at the end. So now these questions you will be answering via a that will be posted here on the chat. And already the link is existing on the description. All right. For this live section, we have the link to you put in your answers. So section you would be given several questions. Just write down your answers in a paper, go through that link, and already make your answers known. At the end of the day, we get the answers back end, and of course, as you know, as usual, nice gift to one, and also we'll be sending out certificates to those who attentively listens and follow through to the end of the section. We're not going to bore you. I understand that all how the last section was held and how it went. I understand it's really, really. Yeah, I believe it was really, really valuable from the feedback we got at the end of the day from attendees of the last session. Okay, so we are turning data into decision. And we're trying to see how that has been infused for career opportunities. So many of us are from different spheres of study, different career paths. But I want you to understand that regardless of your career paths, we have ways we could infuse data science, data analytics to these career paths. Okay, turning data into decision and career opportunities. So, of course, we know the world is drowning in data. Today, data is said to be the new oil, the new money that we have today because of the valuable insights we get from this data. Some say it's the new oil, some say it's the new electricity. You know, some electricity nobody pays for. So what we actually pay is for the valuable insights that we get from the analysis at the end of the day. So the decision gotten from a given data or given data set is what gives it that value. So the world is drowning in data and starving for insights. So that gap is not a technological problem; it's just a judgment one. So all you need to do is step up, pick up this data, make analysis, draw valuable insights, and spread the word. With that, we get value from it. So let's move. I see you guys. Well done, guys. Okay. Okay. So I move to the next slide. So as we move during the course of this, I would like us to just prompt me once you can't see the slide or once you can't hear me. I'll repeat one more time. If you can hear me, just let me know. Okay, we're on slide 2. The real shortage. The real shortage is not the availability of data. The real shortage is just we going in to analyze data that has been sitting unused. All right? So, two-thirds of the harvest rots in the silos. What does that mean? So, it means we have mirage of data and it is not being used. We just make reports, we keep them, we draw different, we extract different data and we just keep them. And we don't try to draw meaning from this data. We don't try to see what is hidden within this data. A lot is hidden within data, within data sets, within this data point. And what is hidden usually, and 90% of the time, is of value. And that could help our direction, that could help our decision, and that could help in rerouting the paths we take to the endpoint. All right? That could keep us aside or keep us on a different standpoint in comparison to the rest persons. And this is what some companies uses to stay ahead of the curve in comparison with other companies. So, just like I've said, organizations are not short of data. They're only short of people who actually go in to break down this data. Storing the data is cheap. Most data are collected and it's never interrogated. And all this I have said. So this is the largest single untapped value pool of all walks of life. You can see the use and the ones that are just still are not even used. 68% are usually not used. They just stay there in the dark. And yeah, the value keep rotting away. 32% is actually put to work because maybe it's data that we use in our day-to-day work life. So it is good we go beyond that and we try to broker the data we usually would have. Okay, so imagine in your first job, the fastest way to look like a senior is to find this data that nobody opens and bring the visual analysis to the hierarchies and the top guns so that they are able to see the value firsthand and you will be highly sought after. Okay, so to the third slide, we have the definition that sticks. So it is not about the data, it is about the next move. All right. So the data is the data, the analysis is the analysis. Now, at the end of the day, once you have a visual analytics placed in front of you. From the visual, you're able to interpret. From that interpretation, it then gives you a route to decide on what path to take. So now the point is that path to take that is already placed in front of you, are you taking that path? So the data has done its bits. You have also done your bit. Now the decision is now left to be taken and to draw value from whatever you've seen. Data science is a discipline that helps reduce uncertainty before a decision is taken. Every project answers one of the four questions. And I'll just go straight to what we have on our visual board. We have prescriptive, predictive, diagnostic, and descriptive. So you could call the prescriptive, what do we do? You know, call this 80 first. Here's the script. 80 data points. Here's the script. What do we do with it then? Now, predictive. What happens next? We could have some mirage of data made available to us. We subject this to some modeling, machine learning modeling. And with this, we're able to predict, we're able to forecast for the future what happens. And in that forecast, we're able to take a decision on what to do to avert whatever value or whatever insight we must have gotten from the data analysis we had done. So imagine you are running a mall and you're beginning to get some sort of downturn when it comes to customer availability and visit to the mall. You're able to run some predictive analytics and you understand that this downturn might still persist in the next month. So the data and the analytics you must have done will inform you that this is a possibility. So it's now left to you now to make moves and step on the reason why this possibility would come to fusion. We have a diagnostic. Why did it happen? You're able to predict. You know that, okay, in the next month, say by June, that 400 customer might leave. Now the question you ask is why would they leave? What are we doing wrong? What are we doing right? And this is contained in the data you must have extracted in the beginning. It could be that a particular clan or a particular tribe are not too good with whatever it is you have in that mall or whatever customer care methodology or culture you have at the mall. So it might mean that you need to step up or you need to train your customer care team. It might mean that, okay, there are goods and services that are contained in the mall that they don't buy into. You look at the trend of things that they buy and you might want to increase that. You know, this is you gaining value from the data you've analyzed and getting to understand what some part of this population or demographic you have are more in tune with, more in tune to. So with that, you're able to solve those little problems, and at the end of the day, you are able to keep your customer and don't have them churn. Now we have descriptive. What happened? Sales fell 12% in March. We have a dashboard that tells us this at a go. You know, you're able to ingest this data, do the analytics, and make a dashboard. This is just simply data analytics. That dashboard gives us real-time visual on what is happening, on how the sales is going, on how we are retaining customers. It's more like a customer retention dashboard, sales progress overview dashboard, you know, something to help us with understanding the value and understanding the direction the business is going. So I'm talking about business for now, but understand that when it comes to data science, you are able to use this in every sphere of life and every sphere of study. Okay, now to the real deal, the everywhere factor. So now I want you to clearly listen and understand. As we go through this, remember that questions will be posted at the end of this session. So please follow through, listen, watch the slide, make meaning with whatever you're seeing on the slide, make meaning with whatever I'm saying, and so that at least you make your best effort during answering the questions. Because yeah, you need to read in between the lines, and you need to uh, just justify your clear understanding on what is being posed now. So data science is not an industry as people would think, because everywhere you hear is data science is not. It's not an industry. It's just a layer over every career, just a layer over every one of them. We have come to understand the value of data, the value of data sets, and what that value brings. So regardless of your career, you are able to infuse data science into them to create insights and value. All right. So nobody comes and say, okay, I want to make employment and all I need is a data engineer or a data scientist, or, you know, um, a data augmentator, one who augments the data, one who cleans and, get it ready for analysis. Nobody does that. So what they do is they just hire someone who can fix their problem using the data that exists within the organization or within the company. So the domain is the main job. And by domain, what that means is your domain could be in the commercial sphere. You could be a banker. You could even be one who works in a commercial entity. You could be a drilling engineer, process engineer. You could be one who has read mechanical. You could be one who is into the lab tech, laboratory scientist. Yes, mirage of career discipline are the domain. All you just need is the domain understanding, domain knowledge. Once that is done, you take data science as a tool which you could use to better that particular field. So the tools are just the tools are just what you need and how you're going to use it to create value. 86% of employers worldwide expect AI and data technology to help their business by 2030. And I know every one of us are beginning to feel this. You're beginning to see this. You're beginning to see companies, organizations now tending towards that possibility. Companies are now infusing AI technologies to their way of working. Some are not there yet. Some are way ahead of the rest. Some are ahead. Some are retracing their step. Some are ahead. Some are retracing their steps. Um, Some are trying to make sure it's more like a hybrid situation before they completely move towards the full AI bloom. So, but the understanding is that everybody is in that race towards trying to ensure that they infuse the value gotten from the AI and data science, you know, to technology to shaping their business and to bring value. If you look at the visualization I have just posted on the right hand side, you could see how this is being used in the health sector, also in sports, the energy sector. I mentioned drilling, the finance sector, the banking, how fraud is being caught. For the health sector, how we could actually deduce sepsis before it goes beyond situations where it can't be handled. For sports, you can use the analysis of a player to tell if the player could be the right signing or not, right? By way of checking out the number scored, even the number of injuries the player must have gotten, and how long it takes the player to even recover. Because you wouldn't want to get a player, and after one injury, it takes the player 6 months to come back. So all these, you just use this to see how you create value or you get value for the progress of whatever business you're into. Aside this four particular jurisdiction I have mentioned, we can use this in agriculture, yeah, journalism, elections. Of course, this was used by the Cambridge Analytics, although that got them into trouble because, in as much as you use data, you need to follow the extraction of data ethically. So, data ethics is also very, very important. We could use this for logistics, the climate, the music industry. Now you can use apps like Suno to create music, and there is another which you could use to create music videos and sell them online. For the insurance company, and of course, you could use this to deduce how customer comes in to buy products, insurance products that you might be giving out, and which of the insurance product might be valuable or viable to customers. We have the urban transport and also conservations. Okay, all these are not just hearsay. This was gotten from the Economic Forum, technical papers, Future of Jobs Report 2025. Yeah. Okay. Give me a love smiley. Give me a thumbs up if you can hear me up to this point, and if you are getting insights and value from this session already. Okay. Yeah. I see you. I see you guys. Okay. So this slide speaks on giving you proofs and making you understand that the data science AI boom is no hype. I had mentioned the health sector, things about sepsis, how to make better decisions and avert issues and problem. Imagine you are able to deduce sepsis 6 hours earlier. Imagine what gains that would be to the medical sector. Sepsis kills when it is spotted late. So the data to spot it early was already in the hospital record, but nobody looks at that. But this was first done by the Cleveland Clinic to put AI screening model inside the records of of individuals and create a dashboard to in real time give them visuals on persons prone to the sepsis and to be sure that it doesn't go out of hand before it is noticed. So the wins here was having smarter model and fewer false alarms. So it is really, really important. We see how we infuse this to our day-to-day job and our day-to-day activities. We try our best not to keep data unused. Try to see what value can be gained from data that are stale, because stale data are what you need. If you follow through with the news nowadays, you imagine that old books, old materials are not what people are going back to. Old materials from the library are now being scanned and sent, ingested by AI just to help its accuracy, help its knowledge, help its knowledge base, and improve the way it decipher decisions and the way it brings insights to persons. So on my right, you could see 46% more sepsis cases were identified. We had 11 fewer false alerts for this particular clinic and 35% drop in risk-adjusted sepsis. So sepsis mortality was reduced from 2022 to 2025. And with more data, you could imagine what value and gains will be had in 2026. So this was a report presented by the Cleveland Clinic September 2025. So this was validated and published, and this is a good use case. Okay, remember at the end of this section we'll have quizzes, certificate will be given. But the quizzes, I want to see us ace this quiz. A lot will be given out at the end of the day. Once you clearly show that you followed and understand clearly all that is contained in this presentation slide being used. Okay, I want to bust some sort of myths that are making the waves. I was speaking to an undergraduate recently. I said, "Oh, why not just take a brief course in maybe data science or data analytics? It will take you maybe start from 3 months to about 6 months, and with that, you should be good enough to be able to apply that to whatever you're doing or whatever you find yourself in." And she was like, "I don't like coding, right? Coding was my problem while I was in secondary school. I wasn't good with that. So, well, I'll tell you that coding is the last thing you really need. You only need maybe 10% of coding knowledge, but all you really need first is the zeal, the curiosity, and the ability to critically think out things, think out areas, find possible places to get to bring value, and from there you have your domain knowledge. I've explained domain knowledge before. Domain knowledge is just simply the career path you have taken and the knowledge you have amassed over years on what specialty you decided to run. So you need a huge part of interest, curiosity, and critical thinking. Then another huge part is the domain knowledge. Then you start looking at the tools to be used to help your analytics. A lot of persons use the spreadsheet, the Excel. You could also do that. Move from Excel to SQL. These are languages that could help with your analytics. Not languages that could help with your data modeling. Just you can see just a little of that you need. Then you later on can start talking about the coding and maybe the mathematics backend. I would let you know that AI is now as smart as one. It's unbelievably smart to the extent that it can help you with the coding. So you just simply need to prompt better, discuss with your AI what you intend to achieve. You see, with your curiosity, you have found an area you intend to solve problems, and with your domain knowledge, you already know how to go about it, what is feasible and what is not. And with your idea of tools, you know what tools you tell the AI to come up with in trying to solve whatever problem or areas where you have observed issues to dig in. So you can see how things are looking pretty smooth and pretty easier to come by. So all you just need is yourself, your brains, and you can work with your AI tool to immediately give you answers to serious problems. Okay, so thumbs up, give me thumbs up, give me thumbs up, and love smiley if you can hear me and you are following really well. So you can see the pro tips there. Python can be learned in 8 weekends. Just put your mind to it in case you want to learn Python. Python is a coding software. It could be used for several things, for data analytics, data modeling. It could be used for to build apps and all. So the point is just knowing which question to ask is what is really important. Okay. So I'm trying now. Let's now demystify and let's go through some existing workflows. And these workflows is a constant anywhere, any day, anytime. It's a constant. As they call it some data analytic workflows, data science workflows. And these are steps you take to get to the finishing point. And these steps, you can imagine, okay, you know this workflow. You are just going to prompt your AI to say, okay, I have this problem, but first, this is the data set, meaning the data you have extracted. That's data sitting somewhere unused. You have extracted the data. You look at the data, be sure. Usually, when the data comes in, they are usually not good enough, like not clean. You could have some numbers in columns, some not in columns. You have some columns empty. You could just have letters in columns that are supposed to be numbers, you know. So there you need to just clean up that data. It is best to clean up the data. Unable to clean it, you work with AI to help you with the cleaning and the rest. But still check that there are no hallucinations when you do that. Get the full data and you try to explore. You could use your Excel to explore. You could use your Python to explore. You could use SQL to explore. Different data analytical tools to do the exploration. And by explore, I mean to analyze. You could have bar charts, pie charts. You could have, stacked bar charts. You could have multiple bar charts. You could have what we call it scattered plots or even box plots. Well, these are just exploratory data analytical visualizations to give you at a goal what is contained in the data set that you have. So just go. First, we obtain the data set. That's the source, that's the ingredient. Pull it from the database of the organization, of course, with permission. It could be from sensors. I know in the operations department, we look at what we call the, the Pi Vision, where you have the ability to pull data from sensors. There are surveys existing, people who do some research courses, masters, PhD, who send surveys, and this survey comes in with data, or comes back with data. This data can then be analyzed. You could also source for data using APIs to different online platforms. With that, you're able to tell, take some decision to know what market is bad, to know what meal is bad, depending on what you're looking at. So the skill you just need for that, I had mentioned SQL. You could just use your basic Excel. You have Python and what have you. Then number two, we look at Scrub. Scrub is what we call cleaning the data. We're trying to clean up the data, fill in the blank spaces, check for duplicate entries, remove duplicate entries. Check for biased figures, outliers. Be sure that the outliers is relevant. If they're relevant, you keep them. If they are not, of course, you need to take them out. So you can have a data containing values within the 1000s, and next thing you have a data with 1 million at one of the points. That's clearly an outlier and something that might bias your data. So it's best to clean it up, take that out, or you go look for the reason why that is there to be sure that it is not actually real. But if it is, you have to keep it there because there's a meaning to that. There's an insight to that. So this is more like 38 to 45% of the time the data scientist takes on data. For me, I say 80%. I would say 80% of what a data scientist need to do on a data set is to clean that data properly. If you need real value, true value, value that will bring insights, you spend enough time in cleaning up this data. And after cleaning up the data, the world is yours. Because whatever analysis or insights you gain from that data, you are sure that data is real, that analysis is real, that insight is real, and that insight can fly any day, anytime. So now, after the cleanup, you then try to explore the data. Exploring the data is making some visualization. You could start with some Univariate analysis. By univariate analysis is picking one feature and trying to see the spread of that particular feature. You could go with bivariant analysis. You're pitching one particular parameter against the other parameter to see their relationship. All right. You could go with multivariant analysis. Now you are pitching more than two parameters. They could be three, four, five, and trying to see how they relate to each other, to see their collinearity that exists amongst them. All right. And if you were going to go past exploration to modeling, then you need to look at the collinearity because we wouldn't want so many parameters linearly related to each other because we want to form a relationship. All right. There are different type of modeling. We have the linear modeling, which is the linear regression. We have the logistic regression. We have the ensemble models, and the ensemble models are models like the random forest, decision trees. Um, Let me try to remember more. We have the decision trees, the random forest. We have the gradient boost. We have the SG boost, and we have just name a lot like that. But this we can apply depending on the kind of data sets that we have. I will go to the explore again. They will have what we call the exploratory data analysis. You taste the data as you go, plot it, count it, find the weird thing there, find your outlier, find insights, value. You know, this is where the insight actually happens. It's where the insight actually lies. It's basically all about your chart. When it comes to the modeling, now you're now trying to move past just simply analyzing to subjecting it to some mathematical assertions, mathematical concepts, to see what more can be gotten from this data set. So the famous part. So the skill here, there are libraries on many of these tools, the SQL, the Python, that could help you with the modeling. I had just mentioned the different type of models. Could be linear regression if what you have are numerical in nature, I mean the data set. It could be logistic regression if what you have is both numerical and categorical. Then it could be the ensemble model, which we call the black box model, which is the random forest, decision trees, SG boosts models, the gradient boost models, those ones. Once you have numerical data, you could use them and what have you. So they are really strong models that run high compute backend. So once this is done, you get your results churned out. Then you need to be able to interpret these results. And the interpretation is key. When you explore, you should be able to interpret the charts that you have. When you model, you should also be able to interpret the charts that you have. And this is where the value is gotten. This is where the value is created. So give me love smiley, give me thumbs up if you are really into what I've been saying. And if you can hear me up to this point. Yeah, okay, good. Okay. So imagine you've been employed in a place or in a space and you're able to do this. You're able to just keep bringing values to the high authorities. Of course, you understand that you will not remain where you are because you are valuable and the higher authorities will need you very close by. Questions will be thrown at you and tasks will be thrown at you. They say the reward of good work is more work, all right? Of course, more work is more money. Okay, going to the next slide, and this is for you. Whatever you study, I have kept mentioning this. So take note. Uh, it doesn't matter what you studied. Whatever you study, wherever you studied, what domain you are into, you can apply data science to it to create value. So imagine backgrounds we have history, literature, biology, chemistry, economics, business, Psychology, sociology, there's already a data science skill. So we start with the history literature. You interrogate a bias source. You're building an argument from fragments. You see, there are different aspects of data science. We have that where we talk about the null and the alternative, the null case and the alternative case. You create an argument, and from the argument, you try to use statistics to now redirect what you have, to model what you have, and come to well, a unique conclusion. So where does this pay? You have data ethics, bias audit, narrative reporting. When it comes to biology and chemistry, you have control groups, replication, correlation is not a cause. You're able to just tell what to do. Imagine you have some analysis you carry out in the lab. Yeah. When it comes to where it pays, you have A/B testing, clinical information during the periods of coronavirus, right? Okay, yeah, an antivirus now. Most of these go through clinical testing. Whatever a drug or whatever solution that is being given, understand that they must have gone through some clinical testing, and after the testing, it is now deemed safe to be used on people. Most times, these are used on animals. We see the reaction over time. These are statistical steps that we take in testing this. And what informs this? This is also data science. Yeah? Some high-level statistics, high-level statistical concepts that are being used for this. We have now economics, business, talk about incentives, trade-offs, knowing which metrics that drives the money. I spoke earlier about a mall as an example. How come we have 400 customers going to be leaving in the next month? Or from our analysis from the sales of this month, we have about 200 who are not really coming back. So how do we drive the sales? How do we drive the money? So from data science, data analytics, and modeling, we might get to understand that, okay, if I start giving incentive, if I start giving some percentage discount, I start having some trade-offs with some goods and service, I could gain some more customers, or I could even retain most of these customers. So where it pays, malls, products, business analytics, pricing, and even decision to take risk or not to take. So when it comes to psychology, sociology, we're talking about survey designs, sampling bias, and how human actually behaves. We have that data, and that's the data the world uses today. And that's the data AI is actually hinged upon. Could actually predict the step a human will take. You know, we have the UX research, we have churn and not churn behavior. When I mean churn means people who leaves or people who are retained. So the banking system also uses this modeling technique. Even those in business uses this modeling technique to tell who churns and who doesn't, to be able to predict and get prepared. I start getting prepared to be able to deduce solutions to increasing the retention degree of retention and then reducing the degree of churn. All right. So it is important, as I have said, that it is not about data science as a job or a task. It's about you being able to infuse that to wherever you find yourself. Create value, create insights, and you will be good for it. Okay, I still remind us that at the end of this section, you will have to face some tests. I want to see how well you have followed and how well you have enjoyed this section. All right. Take notes of numbers, take note of some key information, take note of some technical papers, because these are not just manufactured. These are key information from existing papers, key numbers, as to what we have as of today and what is in the open domain, right? So the AI thing, data science thing, is not a trend. I've gone through 4 different technical papers, well cited below, and have you see what the labor market is saying about all of this. So we have 34% projected growth in the US data science job. This is from 2024 to 2034. This is like 10 years. It's projected, eh? So have your gears on and get ready. So you're covered, eh? Just do the needful. Get this as a value added information or a value added part that you just need to add to whatever you are doing now. Nothing is ever lost, all right? No knowledge is a waste. So this is against the 3% for all occupation, about 23,400 openings a year. So each year you have an opening, we need persons to come in. You see, this is open to all spheres of life. Everybody, regardless of your country, you can work online for an American company, for companies in Europe. The point is, be able to prove yourself, to prove your worth, and you're in automatically. All right. Do not always chase degrees and certificates. Be sure that while you chase them, you understand the knowledge that it gives. I will come and say, oh, I've got degrees in this, that, in that, and at the end of the day, I'm not able to even defend it when a little question or minor question is being asked. So you can see the average salary. You can use your calculator and try to change this to naira and see how much that is annually. So this is just a median annual wage, US data scientist. So the median across all US occupation was previously $49,000, and now we're looking at a whopping $112,000, right? And it is more because I personally have seen that of between $180,000 to $220,000 as an annual wage for persons with such knowledge. So, right, wherever you find yourself, imagine you with your domain knowledge and also you understand the data science technique. You know that you will be highly sought after. So you know that you have more option and more room to switch or to remain, right? So when we go to what the World Economic Forum has said, we have plus 113% growth for big data specialists. The world is the world's fastest growing job. Big data. Big data is about data that exists in the world. It's a lot and it needs a lot of compute because most of the AI tools, large language model that we use today are actually powered on big data. And of course, they need high compute, immense compute to ensure that output from this particular platform, you get them as fast as possible. So 72% of organizations already use AI in at least one function. I will take our particular jurisdiction as an example, and you can see we have 1 or 2 LLMs people use. A lot of persons uses even 3 or 4. Even some of us on our phones, of course, the popular chat GPT is in there. People now talk about Claude. Claude has been super good. And we're talking about Grok now. Grok has got superb agents that can do a lot. All right. So I would want us to really expose ourselves and get enlightened and be sure that we are up to date to what is happening out there in the world. Okay. Remember our test at the end of the day. And yeah, I would also post the link on our chat, but also the link to the test would be on the description to this particular YouTube session. So be on the lookout for it. So the roadmap now. You don't just start at the top, of course. You need to grind, get some good foundation, on ensure a foundational base is tight and is able to carry whatever we are building on top of that. So every run is real. Currently advertised job title, nobody skips one run. Just take it one step at a time. You are never late, but just pick up from wherever you are, and yeah, and see where you get to in the next 3 4 months, in the next 6 months, in the next 5 months. A lot can be done in a month. At least when you look at where you are now and where you will be after 1 month, you know that there's a difference. So I give you from year 0 to 1, you can start here. Data and business analyst, just data analytics, just analyzing, chat. You ingest your data set, clean up the data, and you do simple analysis. You just simply analyze and see the insights you get from such analysis from your chat. So you could apply for jobs like the reporting analyst, marketing analyst, operations analyst, research assistant. There are jobs for that. All you do is just learn this for 6 months to 1 year, and you're qualified for this existing job. All you just need is to show the talent you have, or to show that you understand and you know how to do this. When it comes to year 2 to year 4, then it is good you have stepped up from just analysis to modeling. So you're able to model, you're able to play around with the Python software, you're able to understand advanced statistics, and the A/B testing. These are still within the advanced statistics sphere. With that, you can go apply for a senior analyst or data scientist role. You now own a question end to end, and yeah, you're able to deploy whatever solutions you must have gotten. Always understand that you can start anywhere. It could be rough. It doesn't have to be very clean. You do your analysis, you do your modeling, deploy your solution, and show it. You need to show it because they need to see that clearly you have been playing around things like this. Hmm? From year 4 to year 8, you are now a specialist or a lead. A machine learning engineer, you could apply for such, a data engineer, analytics engineer, product data lead. You could go deeper into machining or even have wider influence. You could now decide to open up your own AI agency or consulting agency, because the level of skill you have is highly sought after, and the level of skill you have is something you can on your own pull strings for value. So aim for analyst first, not the data scientist, because of course there are more to read for data science. The title with the word analyst, hire generalists from every majors. And in 2 years, inside the building, build more competence. And with that, you can move ahead. So for 8 years plus, you'll be talking about being the head of data, or the chief data officer of a particular organization or any given organization, right? Being the principal scientist or director of analytics, or even a founder, like I've mentioned. You can even be a founder at year 4 if you truly know what you're doing. And being a founder, the world is yours to control. All right. So the job stops being technical and becomes a judgment. So, or you decide what to do at that point in time. Okay. Remember, remember. I hope you're getting ready for our test, because we are getting towards the end of these slides. Give me thumbs up or love smiley. If what you've been hearing, and if everything has been really, really of value, and if you clearly understand what I have said all along, or what I have been saying all along. Okay, so you could start tonight. Today is Friday. Thank God it's Friday. You could even start today. Give yourself a 90 days learning streak, right? There's no degree required here. It's just you learning, doing, modeling, and creating a portfolio on what has been done. All right. You might assume day 1 to 30, you try to speak the language being used for analysis or for analytics. Learn to ask, not to code. You have the spreadsheet, your Excel, spreadsheet properly. We have the pivot tables, lookup, the charts, basic SQL, you know. You have the Python. Just take them one step at a time. Do not rush. You pick one tool and try to go into the tool as much as you can. You pick the other and try to go into them as much as you can. Understand that while you go into them, get a data set. Use a data set to go into them, not just I'm trying to learn uh, what a particular concept is in SQL. Yes, you understand the concept, but try to play the concept on a data set and see what happens. All right. And as you play that, it is good that you put that down somewhere as part of what you have done. I've played around SQL. I am able to extract the data. I am able to, that's what we call ETL. I'm able to extract. I am able to clean up the data. I am able to transform the data. You know, as I transforming the data, I'm able to then maybe just make simple analysis of the data. You know, you could write one paragraph a week explaining the chart that you saw in the news. So this will just help you with honing the skill of being able to draw insights and value from whatever chart you have made or whatever chart you see. Because a good skill is being able to interpret clearly what you have seen or the results of whatever analysis you have made. Then we'll go to with today's 31 to 60. So you now have to get your hands really dirty. One messy, one messy real data set. Try to clean it up. It might not be the best cleaning, but you keep at it. Ask questions. Remember, I have said you could also work with AI to help you with this. But while you do that, get to understand what to expect so that when it hallucinates, you clearly understand where it has gone wrong. So you pick the data from your word. There's a platform called Kaggle. You go to Kaggle, there is a lot of data sets to be used. You can play around data sets from Kaggle and use them for your tests, for your analysis. All right, clean it yourself. Fill the 40% or or what I call the 80% aspect a data scientist will do on the data before you take it to visual analysis and also its modeling. Add Python or R. I like Python. R is also good, but you can start somewhere, whichever is your choice. But Python is now generally being used, or I would say it is mostly used by persons. You could start with Python too. Then you move to day 61 to 90. Try to be findable. By that, a lot of you guys are already on LinkedIn and all. So once you're there, please post what you have done, post what you're looking at, post what you intend to do. And even if it is not clearly finished, you could even ask for some help online there. You have persons who are doing this, and persons you could send direct messages to explain to them what you are doing and where you are stuck at and what help can be given. A lot of persons on there are ready to help you. So you have one page, the question, the chat, the recommendation, and that is clearly a portfolio. You finish up a particular data set with analysis and modeling. You go in, okay, I picked up a data set. It is about customer churn from a mall. I was able to make the visual analysis, univariate, bivariant, and multivariant analysis. And this is what I got to understand from it. And finally, I modeled it and I got an accuracy of 90, 80, or 60 something percent. So meaning that my model understands the variation in the data set 80% of the time. And that is enough for a portfolio on that particular project. You leave that and you go to the next project and you continue like that. And before you know, on your page, you have loads and loads of portfolio that you must have built over time, right? Okay, so this also applies to the analyst role. You have a chart and you're just able to explain the chart, and yeah, it is good. It is good. You could also watch some of these ways to carry out this analysis and modeling on YouTube. You could join some boot camp, and you'll be good. All right. Notice what's missing: no boot camp, no masters, no math prerequisite. Just one finished, published piece of thinking could get you straight up to the world. Right. Okay, and I think this is our final slide. Remember, after this slide is a quiz where we land. The data doesn't decide. Now it is you taking the decision. You taking the bull by the horn to push forth, to bring insights and value to yourself and to whoever you wish to solve problems for. The scarce thing was never the data. Data is available. It is still. It is not in use, but you can pick it up, try to ingest it into whichever tool that we have explained through this section, and apply some mathematical concept to them, and try to bring value out of this data. It is just about one who is willing to turn this data to clear decisions, to clear value, draw insights, and you should be good for it. So every industry is hiring that right person who has that curiosity, that interest, who is self-driven, and who is pushing without being told. All right. So your first move is small, just one data set, one question, one page, and a publication or a publishing on the usual LinkedIn. It could be other sites, not necessarily LinkedIn, but imagine you were doing that one step at a time. Don't wait until you have a degree, you have a master's before you start doing that. You don't need that. It's not important. All we need to see is what you can do with your messy hands. All right. So at the end of the day, you should have the feeling of I have arrived after a few months. Trust me. You can begin badly. It is never wrong. Every one of us did at one point at a time. Never understood clearly what it was all about. Whatever we're learning now, we never know. We only just took our time to read about them, to study about them, and now we're good for it. So take that bold step too. Don't be shy. You could say whatever you need to say in public. You only will be corrected, and that will consolidate your knowledge when it comes to that. So, gentlemen and ladies, it has been good having you for this past few minutes. I will call it few minutes. I think it is close to an hour, right? So it's good having you guys, and yeah, I would say thank you for listening. Now we go to the the quiz. Just I have said, we go straight to the quiz, and I would put up each question page just for 30 seconds. When I put up the page, I would check my timer. Understand that the link to this is on the description of this section link for YouTube on YouTube, and it will be posted on the chat. Do we have it posted on the chat yet? The link is posted on the chat on the description. Okay, so we have it on the description. So please give me thumbs up if you're able to find the link on the description before I start up the test. Is on the chat now? Okay. So now, good, good. Thumbs up, love smiley if you can already see the link also on the chat. Okay, okay. Good, 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 good. So I guess we are ready, yeah? Okay. So to our first question, understand I am only going to leave that question for just 30 seconds. So, and it starts now. We have two questions on there, right? Question one and two. Question one is, what is the central promise of data science in this deck, in this slide? To produce more data sets, automating every role, enabling better decisions, replacing domain experts. Question two, which is on here, what share of enterprise data is put to work and what is the remainder called? I showed you on the slide the percentage that is in use and the percentage that are being kept unused. All right, we have A 68% archive data, 32% dark data, 32% raw data, 86% unused data. Take note of what you have ahead of the percentage. Raw data, dark data, unused data, archive data. So I'm looking at my timer. Okay, I go to the next question. And now this is question 3 and 4. Can you climb from insight to value? So this question is from slide 3. Which sequence correctly climbs the value staircase? We have descriptive, diagnostic, predictive, prescriptive. Predictive, diagnostic, descriptive, prescriptive. We have diagnostic, descriptive, prescriptive, and predictive. Or descriptive, predictive, diagnostic, and prescriptive. I know you guys saw the visualization I spoke about earlier in the session, and clearly you saw all of this and how they were stated. Number 4 is, why does domain knowledge matter in data science? A, it replaces industry expertise. B, it frames the real problem and context. This is a very good question. It makes tools unnecessary. And D, it guarantees unbiased results. Very super, super good questions, yeah? So the timer is on. Take your time, write out your answers. You could open the link and make your answers afterwards, but the earlier the better. Answer your questions as much as now. I'm looking at the timer. Okay, moving to the next slide. Now, question 5 and 6. Can you connect trust to talent? Question 5 says, which results most directly helped clinicians trust the sepsis alert? We spoke about sepsis and the alert. We saw the publication by the clinic in the US, Cleveland Clinic in the US. And A says 46% more cases found. B, 35% mortality drop, I mean. C, 11 times fewer false alerts. D, 5.7 hours median lead. I know you guys saw this clearly, and yeah, it is good. Number 6, we have, what forms the load bearing base beneath coding and maths? A, advanced coding and maths. B, curiosity, critical thinking, and domain knowledge. C, certificate and job title. D, dashboards and automation. So I believe you saw the pyramid I showed earlier in the slide. There um, you could see how the load was shared depending on what we were looking at. Now the question is talking about The base beneath the coding and the maths. The base beneath the coding and the maths. Good, good. Move to the next question. Can you explain how the work gets done? Question 7 and question 8. Question 7. Which two OSEMN stages does the deck say are where carriers are won? A. Obtain and model. B. Scrub and interpret. C. Explore and model. D. Obtain and explore. Yeah, you must have seen the steps, the workflow, which I explained, that are usually a constant when it comes to data analysis and data modeling, the steps that are important. Question 8 says, which degree to data science mapping is correct? Yeah, we had a table which we looked through when it came to the degrees and the career path of persons and how data science is being infused to them. We have A, history, predictive maintenance. B, biology, pricing strategy. C, psychology, survey design and behavioral modeling. D, economics, clinical bioinformatics. Yes, good. So I'm looking at the timer. I believe we all remember this clearly. If we're following this, we're very, very interesting part on the slide. Yeah, good, good, good. Okay, I'll move on to the next question. Good one. So for question 9 and 10, can you read the market and enter it? There we analyzed all that relates to data science in the US and its growth margin, average wages and all. Now number nine, we have which set matches the cited US growth, the median wage, and big data growth. We have A 34%, $112,590 plus 113%, B 72%, $49,500 and plus 41%. C we have 23,400, $112,590, 72%. D 3%, $49,500 plus 34%. Then moving on to number 10, which entry role and ticket in does the deck recommend? Which is your first step to the data science world? A. Data scientist, Python and calculus. B. Data business analyst, SQL, spreadsheet, one clear story. C. Machine learning engineer, cloud certification. D. Research director, a master's degree. So, which of this is the entry role and ticketing recommended on the slide? Okay, looking at the timer. Okay, I'll move on to the next slide, which is the final slide. We just have 12 questions. And it says, can you turn the roadmap into action? What should exist at the end of the 90-day plan? What should exist? A. 12 course certificates. B. A published page with a question, chart, and recommendation. C. A full machine learning platform. And D. An unpublished notebook. Let us know. Question 12 says, what small first move is the audience challenged to make? A is wait until fully qualified. B, enroll in another degree. C, one data set, one question, one page, and publish. D, apply only for data scientist role. Yeah, I keep the timer on. Yeah. You would agree with me that this has been a super nice section, and the question are strictly related to what has been said uh, all along on the slide deck, and this is super impactful, and yeah, this is great, and I believe a lot of you would do the best. I believe. Trust me. Once we get several bests from this quiz, a lot will be given. Understand the certificates also will be given. So we would go, you see, what we had last week, AI from curiosity to competence, and now we're looking at data science. These are just on a high level. We're making now a step-by-step deep dive into the various concepts in data science and also in AI. And with that, we will now be equipping you with the necessary tool that you need. So it's just you stay tuned to Master Sense by Faraday. At the end of the day, you'll be good for it. This will get you prepared for the future with confidence and with assurance that you must get something of value even while you're in school and even out of school. Thank you, gentlemen and ladies. And with this, I think we will call it a session. All right. Give me thumbs up and love smiley. Thumbs up and love smiley if you enjoyed this section. Good, good, good. I can see you guys. I can see you all. Good one. I see you, Chris Dan. I see you, Yisa. So I see you. I see you, Frank Friday. Good, good, good. Nice guys. Thank you very much. Ensure you go to the link and put in your answer. We will receive it back end, and of course, we would already make the announcement, sending certificates and prize gifts to winners. Thank you all, and that will be it.